BusinessNet Explorer, product news podcast channel. This is B&E Product News, supporting specifiers and buyers. This podcast is sponsored by the B&E Product News podcast library. Well, hi, this is Mick de Leyburn for BusinessNet Explorer. In this edition of the B&E Brand Leader interview podcast, we explore how static build-up in commercial premises can be effectively prevented by managing the indoor humidity level. Dave Marshall-George, UK Sales Director at Humidity Control Specialist Condair, joins us on the phone to help us to understand a bit more about static and humidity. Well, hi, Dave.
Hi, Mick.
So, Dave, to start with, what do we mean when we talk about static?
Well, I think in our day-to-day lives, we're most familiar with static in relation to the annoying shocks that we occasionally get. The little uncomfortable jolts when we touch things. They tend to occur when we do things like getting out of the car and touch the door, or dragging our feet across a carpet and touching another person or thing. So what do we mean by static electricity? Well, as the term suggests, static literally means not moving or still. So static electricity means there is an electric charge that's built up in something and it's literally just stuck there. It can't move. And this is the opposite to electric current, which you could think of as the current of a flowing river, where the electric charge is moving. Now, static electricity that forms in an object will stay put until it gets the opportunity to flow to ground, which is what happens when we get out of our car, stand on the floor, and then touch the door handle. The electric charge that's built up gets the chance to flow through us into the ground, giving us a nasty zap in the process.
So why does it happen? How can electricity just build up in something?
Well, technically, Mick, it's the result of an imbalance of electrons. As two surfaces come together and there is friction, electrons can move from one surface to another. When the surfaces separate, this electron exchange can lead to an imbalance of electrons across the object's surface. This imbalance results in the electric charge. And when we get out of the car, the simple act of sliding across our seat is enough to create this charge. And the result isn't always the zap or spark that we feel as the electricity finds its way to ground. As we've learned in school physics classes, when we're playing around with magnets and iron filings, positives and negative charges attract, so opposites attract. Now, if a surface has an excess of positive charges, it will attract other surfaces and materials that have a negative charge. I think at some point most of us have rubbed a balloon or a jumper on our hair and then stuck it to the wall. Well, the rubbing causes movement of electrons, leading to an imbalance on the surface of the balloon. This then allows the surface of the balloon to be attracted to the surface of the wall and stick there. Likewise, the imbalance can also lead to repulsion. If two surfaces have the same positive to positive or negative to negative, two objects with like static charges can push each other away without touching.
And although sticking balloons to walls and zapping our friends may be fun, or at least interesting, I'm presuming these effects of static can be serious in some circumstances.
Yeah, absolutely. These three effects of attraction, repulsion, and static discharge cause major problems in many industrial settings. For instance, paper jamming as it runs through a printing press, pills that won't sit in their blister packs correctly, sterile bottles on conveyors that attract airborne dust, or any material that's combustible can be put at risk of explosion due to a spark from static. Some objects are more prone to static buildup than others. For instance, large fiberglass or big metal objects like plane fuselages can build up huge charges. In textile manufacturing, due to the large amounts of friction happening, huge charges can build up. And at this level, there's actually a real risk to health and also electronics. Specifically in electronics manufacturing, electrostatic discharge can wreak havoc on printed circuit boards, and even more so on really sensitive components such as semiconductors, where even small charges that we can't even feel can destroy components and reduce the factory's output.
Okay, so what should a factory manager do who has a problem with static, and how does humidity come into it?
Well, Mick, there are many anti-static strategies that can be employed. For instance, surfaces can be treated with anti-static coatings. Workers can literally plug themselves into grounding cables, or the air can be treated with ionisation systems. But most of these strategies are point of use, and by that I mean they're effective at fighting static in a certain place, like a workbench or on a machine. Now, humidity comes into play due to the fact that the water content of the air is a major factor in static build-up. And we talked about static wanting to flow to ground. Well, actually, it can do this through the air if there's enough moisture in the air to conduct it. Now, for safety reasons, we're often taught that electricity and water don't mix, and to keep them separate. Well, the fact is they do mix, and they mix extremely well. Water is a great conductor of electricity, and it's for this reason that we typically need to keep them apart. And the water in the air is no different. It conducts, and this allows the imbalance caused by electron transfer and the resulting charge that occurs to naturally dissipate through the air. So any atmosphere that is particularly dry will also be prone to static buildup.
And what sort of humidity level are we talking about here for it to be effective as an anti-static strategy? Like a steamy sauna type atmosphere, or something a bit more practical?
Well, actually, the humidity level for static to naturally dissipate is really quite average, nothing extreme. A mid-range humidity of around 45% or more will be enough to effectively reduce static. And happily, this is also the same as the recommended indoor humidity level for human health. And studies have shown that the charge created by activities such as walking across a synthetic carpet can be reduced by up to 96% by managing the room's humidity. And to put actual figures on that, in a dry atmosphere, the charge from doing this, from walking across a synthetic carpet, can be measured at around 35,000 volts. Whereas at a mid-range to high humidity, it's as little as 1,500 volts.
Oh, wow. Well, that still sounds like a lot.
Well, to put it into perspective, Mick, people typically don't notice a static discharge at less than 2,000 volts. So this level is quite normal. But as we've said, it can still be an issue in the manufacturing, which is why manufacturers often need to look at all possible precautions.
Okay, so if the best humidity for avoiding static is a normal room humidity, why is static such an issue?
Good question. 45% RH is a normal and healthy room condition, but during the winter, in heated buildings, indoor humidity can easily and often be below this level, particularly if there's a localized source of heat, like from a printing machine or from a soldering iron. You shouldn't think of a room's humidity as a single figure or a flat level across an area. A room will have high humidity spots near cold surfaces, like windows, and then much lower humidity where the temperature is higher. And in manufacturing, you really need to focus your attention on the humidity of the air where the problem is or could potentially be happening. So this could be on or even inside a printing machine, or where plastic sheets are being cut, or where pills are being positioned on a conveyor. Managing the humidity of an area or a complete factory is a really holistic approach to reducing static buildup and the problems it presents.
Dave, just to explore that a bit more, you mentioned humidity is lower when the temperature is higher, but you also said that it's drier in the winter. So how do those two things fit together?
Yeah, okay, another good question, Mick. To answer that, we need a quick explanation of what relative humidity actually is, and also to deal with the fact that cold air can physically hold less water than warm air. So let's think of the air as a container or a sponge. Now, there is a limit to how much water our sponge can hold, and this limit will increase or decrease depending on the temperature. Cold air is a tiny sponge. It can only hold a little bit of water, so it doesn't take too much to saturate it. And relative humidity is just that. It's a measure of saturation. It's not a measure of moisture content in, say, grams, but it's expressed as a percentage of how much water air is holding compared to its maximum capacity at that temperature. Hence the expression relative humidity, relative being relative to temperature. So when the air can potentially hold 50% more water, so it's 50% full, we say its relative humidity is 50%. And when it's 75% full, it can absorb 25% more moisture, so it has a relative humidity of 75%. Now in the winter, when the outside air is cold, the cold air is a small sponge and it can't hold much moisture. So even a little moisture will saturate it, meaning it has a high relative humidity, let's say 85%. So it could only hold 15% more. Now when that same air comes into our factory and is heated, it becomes a big sponge, and heating allows the air to hold more water. So even though it's got exactly the same amount of water in it, in grams, this bigger sponge is now capable of holding maybe 70% more water and is therefore only 30% full. Therefore, the same air's relative humidity is now down to 30%. And at this level, it's well below the danger level for creating an atmosphere that's prone to static buildup.
So it's the act of heating the outside cold air that increases its capacity to hold water, resulting in low indoor relative humidity.
Exactly, Mick. And that's why the cold winter months are our dry season and the time of year when static is more of a problem.
And what would our factory manager, who is suffering during the winter, static season, do about it?
Well, the simple answer is to humidify. We need to proactively add moisture to the indoor air to raise its moisture content and relative humidity back to a level above 45%. And we do that with commercial humidifiers.
Okay, and how complicated is that?
Well, that really depends on the building, its existing air treatment or ventilation systems, and what sort of humidity is ideal for their manufacturing processes and materials. There's a wide variety of commercial humidifiers available. Some will spray water into the air, some evaporate water from a wet surface, and others will boil water to create steam. Different applications suit different types of technology. And for instance, big factories with huge open spaces often suit high-pressure spray systems. And this is where many nozzles are located around an area and a central pump system purifies and pressurizes the water. This is then distributed to nozzles and released as a fine aerosol. This type of system has a really low energy consumption and can deliver massive volumes of humidity around a building. It's also capable of providing evaporative cooling, which can be another benefit for a factory. If an area is small, like a room with a digital printer or an MRI scanner in, and it only needs a few litres per hour, then often a steam humidifier is best, which is much easier to install, very easy to control, and is an efficient way to control a room's humidity. But there's many more types as well, including systems that will fit in with air handling plants and a building's ventilation system. Deciding which type is best for a job and also assessing whether a static problem can be solved with humidity control is all part of an initial consultation process we go through with clients. And we're always happy to visit a manufacturer free of charge, make an assessment of the building and provide our advice on whether humidifiers can help and also what type and size would be needed.
Okay, well, as a final comment, is there anything else a factory manager should be considering if they're thinking about managing humidity to control static?
Sure, yes. I'd say they would need to consider the whole life costs of the system. So this isn't only the initial purchase and install cost, but also be realistic about the energy and water use and factor in the servicing. All humidifiers need to be serviced, and this ought to be thought about from an early stage. But on the upside, there are many benefits to maintaining humidity alongside static control. Maintaining the ideal manufacturing environments, no matter what the season, can lead to consistently high product quality, reduced waste, and improved yields. And it can also reduce staff absenteeism, as airborne respiratory infections such as colds and flu are reduced when air humidity is kept between 40 and 60% RH.
Sounds like a win-win, Dave.
Yeah, and anybody wanting to know more about a free on-site consultation, there is information on our website, condair.co.uk, and there's plenty of info on static control, types of humidifiers, and also a very interesting section on health too. So go check it out.
Well, that's great. Well, Dave, thank you again for joining us today on this special edition B&E Product News Brand Leader interview podcast, discussing how to control static by controlling humidity.
That's great. Thanks, Mick.
Well, that's a pleasure. Cheers, Dave. For more information about Condair, please go to www.condair.co.uk. And please take a moment when you can to check out the other B&E Brand Leader interview podcasts in this series that feature Condair and provide unmissable insights from Dave Marshall-George on subjects such as exploring the evaporative cooling opportunity for HVAC system specifiers, understanding the relationship between health and humidity is key to optimising indoor air quality, optimising humidity control to increase profits for food and drink manufacturers, and how dehumidifiers can improve safety and efficiency in cold stores and freezers. You can find these on the Condair website and the BusinessNet Explorer Brand Leader podcast playlist. Well, thank you for joining us for this latest edition of the B&E Product News podcast. And please, stay safe. Follow us on Twitter at B&E Product News to keep updated on our latest product news podcast releases, and visit us at businessnetexplorer.com to find more product news and information for specifiers and buyers in the construction and building services and associated manufacturing and energy sectors. BusinessNet Explorer podcasts are now available via the Apple Podcasts app, iTunes and on Spotify. You can subscribe to access our existing content and, of course, to receive every new podcast that we publish in audio format.